All right, so we're going to talk a little bit about Module 3, Lesson 4 today. The first topic that we're going to cover in this is radical expressions. So this is an example of a radical expression up here, a kind of a general one, okay? And what they are is they're the inverse operation of an exponential expression. So in the nth root of a, there's three pieces that make up this expression. This thing right here is called the radical sign. Okay, up top here, this value, which will be a number for us, is going to be called the index. And then the number inside here is called the radicand. So we got a radical sign, index, and radicand is the three pieces there. Okay, so I've written a couple of examples down below. Let's look at this one first. So the square root of 9. If we're going to evaluate that, the first thing you might notice here is that there's no written index on that. And that's because like a lot of things in math, when we have something that's very common, we kind of shortcut a little bit. And so anytime you see a radical sign like this that doesn't have an index up here, the implied index on this is a 2. We call this a square root, and it's the most common radical that we'll deal with. You'll see it a lot in your future math classes and science classes also, if you take some of those with us. So we would read this expression, the square root of 9, okay? So the square root of 9 is equal to 3 because 3 squared is equal to 9. What we're looking for here is we're looking for something that we take to a power equal to our index that gives us our radicand value. So 3 squared is equal to 9, and so the square root of 9 is equal to 3. Okay, similarly, this next expression down here, the cube root of 27 is how we would read this when our index is 3 up here. So what we're looking for here is we're looking for something that we take to the third power that equals 27. And so that is going to be 3 as well, because 3 to the third is equal to 27. You got to pay attention to your index because that's going to tell you what your power is that you're thinking about on the kind of the equivalent exponential expression to put all this stuff together. And that's going to help us get our values. All right, so the good news with the square roots in this class is that we're going to be using our calculator a lot to get the values for these things. So if I have a problem like this one where I'm asked to find the square root of 400, some people might just know that. If you know what value you multiply times itself to give you 400, you're in great shape. A lot of people won't. That's totally fine. It's not a problem to just get your calculator out. Over on the left-hand side in blue, above the x squared button, you're going to see the square root option there. And anytime you want to get to something that's in blue on the calculator, hit the second button first. So second x squared will get you a square root. And you can put the square root of 400 in there, and that'll give you the value. Okay, and this one is a nice value, but they won't always be. Some of our radicals are going to give us irrational numbers, which means decimals that are going to continue without repeating. And so for those, we can't get an exact value, but often we'll just need an approximation instead. So that's what the next example problem here is asking us to do. It says approximate to 2 decimal places if we're going to do the square root of 8. Again, this is just another one of those questions where we need to use our calculator. We hit second and then our x squared button to get a square root, put our 8 in there, and it's going to give us, a whole bunch of decimals here. We do need to pay attention to our rounding instructions on questions like this. If it asks for 2 decimal places, I'm going to look at what it says here at first is, 2.828, and then there's even more decimals after that. I just want 2 decimal places, so I'm going to go with 2.83 here for my answer on this one. Okay, so a lot of these will be done with their calculator. Okay, so next we're going to look at some radical expressions where we have negative values inside of our radicals, negative radicands. Okay, if we look at this first one here, the square root of -8, there's a couple of ways we can approach this problem. You can, of course, just try to put it in your calculator if you want. If you just try to do the square root of -8, and you put that in your calculator is going to give you an error. And this does make sense. If we think about what this radical is asking us to do, what we're looking for is we're looking for something that we multiply times itself to give us -8. And we know that when we multiply a number times itself, if it's positive times a positive is going to give us a positive. Or if it's negative times a negative is still going to give us a positive. So there's no way where we have a negative inside of a square root like this for us to get a real number answer. So this is not real here. You can't do it with negative numbers inside of our square roots. Okay, now this next one though, the cube root of negative 64, if you try that with your calculator, first off, again, you go over to the left. This time it's above the x to the nth button, second, and then there's an x the root button up there. You can type that in there. This one will give you -4. So this one is a nice value that works out okay. Okay, and the reason for that is if you take -4 to the third power, you get -4 times -4 times -4, which is +16 times -4, which is -64. So it works out just fine, right? So we can have negatives inside of our cube root. So this is a little bit tricky. And the trick here, what it boils down to is if you're looking at a radical expression, if your index is even, remember there's no index written up here, so our implied index is a 2. If our index is 2 or 4 or 6 or any even number, you can't have a negative number inside of it. Okay, but if our index is odd, like it was in this problem down here, the cube root of -64, it's fine to have a negative inside there because we're going to get that negative when we do our calculation. Okay, so if you have a even index, can't have a negative radicand. If you have an odd index, you can, and you'll get real numbers. It's very important when you're doing these kinds of problems to really pay attention to where your negative sign is. Okay, this top one up here is not real because we're trying to take the square root of a negative number. Remember, my index up here is 2 if there's not one written. And so it's even, and I can't take the square root of a negative number like this, not and get a real number anyway. Okay, now down below on this other one, that negative is not inside of our square root, so it's not part of our calculation. So we're going to do it second, and we're going to do it kind of separately. So I would start to work this problem by doing the square root of 25, and that is 5 because 5 times 5 is 25, right? And then the negative that was out in front of our radical is just going to come on across. So this one works out just fine, does give us a real number. So it is pretty important in problems like this to pay attention to where your negative sign is in order to work these things correctly. Okay, so the next big topic we're going to talk about in this lecture is these things called rational exponents. So the word rational means we're going to have fractions, and exponent means they're going to be, small and raised up in the exponent spot that we've seen before. Okay, so this is an example of a problem with a rational exponent, 9 to the 1/2, and these are just another way to write the radical expressions that we've been working on. Okay, so if we have a problem like this, 9 to the 1/2, this is the same thing as the square root, okay, with the 9 on the inside, okay? And then my index is going to come from the denominator. So I'm going to have an index of 2. And my power up top, the number up top here, my numerator, is going to become a power on the outside. Okay, so this 1/2 exponent is going to be by far the most common rational exponent we'll deal with in this class, and really in any class. It'll be the most common one that we deal with. So really, the 1/2 power is just another way to say we want to take the square root of something. So 9 to the 1/2 is the same as the square root of 9. And then, of course, that's equal to 3 because 3 times 3 is equal to 9. Okay? Similarly, down here, if we have 8 to the 1/3, this is the same thing as a radical with an index of 3, comes from our denominator, remember, and then an 8 goes inside. And then the 1 up top is going to become a power if it's a 1, which hopefully, I think from almost all of your questions in this, that will be a 1. If it's not, we'll look at how to deal with it. But for most of them, it should be. So really, this is just another way to say that we want the cube root of 8. And this is one, if you need to, you can put it in your calculator. But think about it for a second. 2 times 2 is 4. 4 times 2 is 8. So this is equal to 2 since 2 to the 3rd is equal to 8. Okay, so some of these basic squares and cubes, you want to start to remember them as best you can because it's going to really save you a lot of time and effort. So what do we do if our numerator is not 1 in our rational exponent? Well, it's a similar process. It's just going to have an extra step to it. All we're going to do here is we're going to rewrite this as a radical. Okay, our denominator is 2. That's going to become our index. Our 4 is going to go inside. And then that 3 in our numerator, it's going to come up here and it's going to become a power. Okay, and then we're going to work this out in 2 steps. You should always do the radical part first in general, because when you take the square root of something, if our number is bigger than 1, it's going to get smaller. It's going to be kind of nice. It's not always going to work out, but for many of our problems, it will. So the square root of 4, I would do that first and get 2. And then I would do my power next. So 2 to the third, 2 times 2 times 2 is 8 is how I would get that. Okay, so if we have an index bigger than 1, it's just going to be a power. We're generally going to do that calculation last. All right, so let's look at a couple of examples where we have some signs in here that might make this a little trickier. If I'm looking at this first one, then minus 9 to the 1/2. A lot of people would think right off the bat that this is maybe not real because you can't take the square root of -9. That's not what we're trying to do here, though. What we're trying to do is we're trying to take the square root of the thing that the 1/2 power is on, and it's only applied to the 9 here. So the 9 is going to go inside. The negative is its own separate piece, and so it's going to go on the outside of our radical. And so this is going to be -3. It's going to work out just fine. If we had a parenthesis like this, then this would be not real because we're trying to take the square root of a negative number. Okay, but this one we're not, because the negative is on the outside. It's its own separate piece. The 1/2 is only applied to the 9. And so we'll work it out, get -3. Okay, if we have 9 to the -1/2, well, this is where we have to go back to our exponent rule lessons from Module 2 to remember what to do. If we have a negative exponent, okay, we deal with that by just taking it and moving it down to the other side of our fraction bar. So this 9 to the -1/2 is the same as 1 over 9 to the +1/2. And then 9 to the 1/2 is just another way to say the square root of 9, or 3. So this is going to be 1/3. You have a question in your homework asking you whether a problem like this that has a negative exponent is positive or negative. Well, this one works out to be positive because there's nothing in here that's going to change our sign. All that negative exponent does is just take our whole expression, move it to the other side of the fraction bar, and then we work it out from there. Okay, so the last big topic to talk about in this lesson are these things called radical equations. So we're going to have a radical sign in our problems, and we're going to have an equal sign in there to make it into an equation. So let's look at a very simple one first here to kind of think about what's going on. If we look at something like the square root of x equals 4, with a little trial and error, you can probably kind of figure out that x needs to be 16 to solve this question, because we're looking for something that 4 times itself gives us. So this is going to be 16. But like I said, this is a simple problem, and they will not always be this simple. So we need a way to solve these equations algebraically. Okay, so let's look at this same equation again, and let's see if we can get there with some algebra. So if I have the square root of x equals 4, what I'm going to do first here, if I want to solve this thing without just kind of figuring out the answer, is I'm going to square both sides of my equation. Okay, so the reason why this works is because the square root and the square, they're called inverse operations. They undo each other and cancel each other off. And so that x is going to be left by itself over there. And on the right side, we're going to have a 16. Okay, now when you do this, when you square both sides of an equation, you have to be very careful. Let's look at why. If I look at a very similar question, think about this one. The square root of x is equal to -4. Okay, I'm going to kind of follow the same process. If I think about it for a minute, maybe I can come up with the right answer, but I'm just going to solve it algebraically. I'm going to try to square both sides of my equation. And then again, just like we saw before, the square root and the square undoes each other here on the left, leaves us with an x by itself. -4 squared on the right, -4 times -4 is equal to +16. Okay, so it looks like we get the same answer, but if we take this answer and we plug it back into the original equation, we get this, and we know the square root of 16 is 4, right? So I got something that is just incorrect when I plugged it back in. And so what that is telling me is that this answer is also incorrect. So this is something you have to be very careful of. When you're working with radical equations, you will often solve them by squaring both sides. But as soon as you do that, as soon as you square both sides of an equation, you have now made checking mandatory. You have to check your answer because the answer that you get is a possible solution, not the exact solution. And often these answers that you get, like this x equals 16, will just not work when you plug them back in. Those answers have a special name. They're called extraneous solutions. Okay, so this x equals 16 is an extraneous solution. We have to kick it out. We can't keep it. And so there's no real solution to this equation here. Okay, so this is an important thing to keep in mind when you're working with these radical equations. When we're solving them, we are going to square both sides pretty often. And as soon as we do, what that means is we have to take our answer, plug it back in, check it, and make sure that it works and that it's not extraneous. Okay, so let's look at how to solve a little more involved radical equation now. So we've seen how when we have a square root, we want to get rid of a square root. When we have an equation like this, we can square both sides to make that happen. But before we do that, we need the square root to be on one side by itself. So that's my first step in these problems is isolating the radical. I want to get that square root on one side by itself. I'm going to start by moving this 2 over to the other side, getting rid of this. Get that square root on one side by itself. Okay, and then our next step is, well, we need to get rid of the square root. So we're going to square both sides. And I've got to remember, as soon as I do this, as soon as I square both sides, I have to check as my last step on the problem if I want to make sure I'm getting it right. Over here on the right, 4 squared, 4 times 4 is 16. Okay. And then our next step here is to solve for x. So I'll move the 4 on over. Just a little linear equation to solve. Divide by 5. And so we get our x is 4. Okay, our final step is to come back to one of our equations before we squared both sides, plug it back in, make sure that it works. I'm going to choose this one right here. You could use the first one as well. It doesn't really matter, but you do need to make sure you're plugging it back into one of the equations before you squared both sides. So if we plug this 4 back in, it'll look like this. 20 minus 4 is 16 over here. Square root of 16 is 4. And so we're good. So we're going to keep this, and so 4 is going to be our answer. But you really do want to check these because you can do all the math correctly, and you can still get an answer that is not correct. So you do need to check them as soon as you square both sides of your equation. Okay, so hopefully that's enough to get you off to a good start with this. This is a tough lesson. There's a lot going on. So please feel free to contact me either through Ask My Instructor or through email. If you have any questions, I'm happy to help.